Welcome to Maths for All. I'm Aisling Flynn. This is Algebra 1.5 Simultaneous Equations. As always, we'll remember the golden rule. I'll point it out when we need it. If you make a change on one side of an equation, you must also change the other side in the very same way in order to keep left equals right. Okay, have you seen any of these puzzles on social media? Take a moment and pause it. See, can you solve? Did you get these answers? Take special care on the last line. Look very closely. Pause and review if you need to. So let's look at the first line. Apple plus apple plus apple equals 30. So this we can easily solve. So what amount added 3 times gives you 30? Well, that's solved by division. 30 divided by 3 gives 10. Okay. What about this next problem? We've 2 red chips and a blue chip give me 17. You have to solve. What are the red chips worth and what is the blue chip worth? Okay, let's have a look. Is it 5 plus 5 plus 7? So are the reds 5 and the blue 7? Possibly. But couldn't it also be 4 plus 4 plus 9? Or perhaps 3 plus 3 plus 11? Or even negative 3, minus 3, minus 3 plus 23. They all give the result 17. So how do we know which one it is? Well, we need more information to say for sure. So here's some more information. So we have the same equation as before. 2 red plus a blue gives 17. But also 3 red take a blue gives 8. So we're going to use these 2 pieces of information together, or use these 2 pieces of information simultaneously. Okay, and we're going to combine them. Okay, so we're going to imagine they're on our desk. We're going to push the red ones together and the blue ones together. Now, because with those blues, one is plus and one is minus, it means give a blue, take a blue, means it cancels to give 0. Okay, or plus 1 minus 1 gives 0. For the reds, we have 5 reds because they're all plus. And on the right of the equals, we combine the numbers. We've got 17 and 8 gives 25. Okay, now this looks far clearer. 5 red chips gives 25. So by division, we can say 1 red chip, so divide by 5, equals 5. Okay, so that's dividing by 5. All right, so now we know that the red chip is 5. If you go back there to the first piece of information, we can say red plus red is 5 plus 5 is 10, and a blue gives 17. So therefore, the blue must be equal to 7. Okay? So red was 5 and blue was 7. We can say that for sure now, given the 2 pieces of information. Now, for the next slide, we're going to call red chips X and blue chips Y. Okay, I'm going to see how this would be written in a maths setting. Okay, so instead of pictures now we have, remember we had 2 reds, so 2x plus y equals 17. And then we have the 3x minus y equals 8. So this would be on your page and you would be asked to solve. So find the missing values. Okay, so our method as before with the pictures was to combine. Okay, so you're looking at x's first. We have 5x. If we look at the y's next, we have plus y minus y. Well, they cancel each other out. You get 0. Okay, and if we combine on the right of the equals the numbers, we get 25. So now you have a little equation, 5x equals 25. Solving for x then, you divide by 5 both sides, just like you did with your before when you were learning your linear equations. And we get x equals 5. Okay, this is called solving by elimination. To eliminate means to remove completely. So we have eliminated the variable y. We've taken y out of the picture, and that allows you to solve for x. Okay, I should mention that it's possible to eliminate x and solve for y, and we'll get to the same result. Okay, so now we know that x is 5. We can substitute for it. So 2 times 5 plus y is 17. That's 10 plus y is 17. Y is 17 minus 10, so y is 7. So just like we got with the pictures. Okay. Now simultaneous. Simultaneous means at the same time. Can you pat your head and rub your tummy simultaneously? Try it. It's a little tricky. To solve these equations that we've just been doing, you must use the information from the 2 equations at the same time or simultaneously. When you do, when you substitute the answers you get back into the equations, they should make both of them true. So the numbers work for both equations simultaneously. Okay, some examples. Solve this one. Okay, now let's look. Remember, we're trying to eliminate one of the variables, a or b. In this case, we're going to look at b. Now, if I do 2b minus b, I'm still left with 1b. Okay, so I won't be able to eliminate it. So I'm going to choose to do something to one or both of the equations so that I can eliminate. So I'm going to choose to multiply the bottom equation by 2. Why? Because that will give me minus 2b, which will cancel out plus 2b. Okay, but always remember your golden rule. If you make a change to the left, you must change it to the right. And what we're going to do is multiply every single thing on the left by 2 and every single thing on the right by 2. So, starting again, the top equation stays the same, and the bottom one is going to be multiplied by 2. So we get 4a minus 2b equals 16. Stop and check that you've multiplied each single bit by 2. And left will still be equal to right. Okay, now we're going to combine. And at this stage, we'll see that the plus 2b and the minus 2b eliminate each other. Okay, they're gone. And what remains? Well, 7a on the left and 42 when you put the numbers together on the right. Solving for a, we divide each side by 7. And 42 divided by 7 is 6. So a equals 6. Now, don't forget to return and find what b is to get full marks. Okay, so we substitute a equals 6 into any of the equations on the previous slide. Okay, it should work for any of them. So whichever one looks easiest to you. Instead of a, we have 6. That's 3 6's. We get 18 plus 2b is 26. 2b is 26 minus 18. 2b is 8. And dividing by 2 both sides, we get b equals 4. So the result of these simultaneous equations, when we have solved them, is a and b equals to 6 and 4. And that's the way I write it there. Okay. Another example. Okay, so here we've got p and q. I'm going to choose to eliminate q. Okay, you can do it with p also. It's your choice. Now, what do I need to be able to eliminate q? Well, I need, first of all, it should be 2q and 2q. All right. But also you need 1 to be plus and 1 to be minus. So they need to be opposites to eliminate. Okay, so this time I'm choosing to multiply the bottom equation by minus 2. 2 to get 2q, but minus to change the sign on the bottom. Okay, remember your golden rule, multiply everything on the left and everything on the right. Okay, so top equation stays the same. The bottom one now becomes minus 4p minus 2q equals minus 20. So everything by -2. Now to combine, as we wanted, the q's are eliminated. Combining the p's, you get -3p, and the numbers, you have 11 minus 20 is -9. Dividing both sides by -3, I get p equals 3. Now, don't forget to find q. Substitute your p equals 3 back into any of the equations on the previous slide. Okay, the p is now 3, and solve. You can pause to check this through. So q was 4. So pq equals to 3, 4. One more example. Okay, now this one looks very different. If you notice, everything is on the left equals to 0. So to use our elimination method, we're going to rearrange first. We're going to have x's, then y's, then equals, and then numbers. So I'm going to move the numbers to the right-hand side. Okay, so you can see x minus y plus 1 equals 0 becomes x minus y equals -1 when you take -1 from both sides. And the plus 13 on the second one now appears as -13 on the right-hand side. Okay, we're going to eliminate the y's. I'm going to multiply the top equation by 5 so that they match. We have -5y plus 5y will eliminate. That's the plan. Don't forget your golden rule. Multiply every piece. Don't forget any. So the top line now becomes 5x minus 5y equals -5. Bottom line stays the same. We're going to combine. The y's eliminate each other. And in x's we have 9x. And in numbers, -5 minus 13 go together to make -18. Solve for your x. Divide by 9. You get x equals -2. Don't forget to solve for y. Use x is -2 and substitute it into any of the equations on the previous slide and solve for y. Okay. Pause at any stage if you need to look more closely. So -y divided by -1 gives me +y equals to 1. X and y are equal to -2 and -1. Now you do it, okay? Do the quiz assigned to this unit and practice with your written exercises. There are some tricky ones towards the end designed to test you, and don't be afraid to ask me when you get a little stuck, okay? Thanks for listening. Here's some glossaries